Hello, everyone, and welcome to another AskIoT video series episode presented by IoT for All, the number one publication and resource for the Internet of Things. I'm your host, Ryan Chacon. On today's episode, we have Ilya Katsov, the VP of Technology at Grid Dynamics. They are a company that is a digital native technology service provider that focuses on accelerating the growth and competitive advantage of companies. And today, we're focusing our conversation around how to build an Industry 4.0 analytics platform, basically how to plan and manage IoT analytics programs in smart manufacturing. So we're going to talk about really what an analytics platform is, how it differs in IoT versus industrial IoT, how to go about building that platform, how to manage it, and so forth. So very interesting conversation you'll find here. Ilya also has written a book that you can find online. It's very thorough book, and I have a copy of it and kind of working my way through. It's fantastic. Definitely check it out if you're into reading more about technology. But I think we'll get a lot of value out of this episode. So please enjoy this episode of the Ask IoT video series. Welcome, Ilya. Thanks for taking time to chat with me today. I appreciate it.
Mm-hmm. Hello.
Yeah. So let's kick this off by having you give a quick introduction about yourself. Just talk to our audience about your background experience, and then also give us an overview of the company.
Yep, sure. So my name is Ilya Katsov. I'm VP of Technology at Grid Dynamics, which is basically a consulting company that works with large manufacturers and brands on different innovative programs that involve data science, advanced analytics, collection of data from IoT devices, and so on. So my personal background is predominantly in advanced analytics and data engineering. At Green Dynamics, basically, I run our technology practices, including data platforms and data science capabilities.
Fantastic. And have you been in the IoT space kind of for the duration of your experience, or is the IoT just kind of naturally made sense given your background?
Well, actually, we started with like data engineering and advanced analytics in several different areas, working with technology companies, like large technology giants and some other verticals. And we came to IoT space essentially like a couple of years ago, and we invest in aggressively into this area, trying to build up these
Sure.
capabilities. Mm-hmm.
Fantastic. Yeah, super good fit, obviously, given everything that IoT is and we're focused on. But for this episode of our Ask IoT series, what we're going to do is focus a lot on IoT analytics platforms in IoT, industrial IoT, and so forth. So let me quickly swap um, to this view for us to kind of focus in. I'm going to bring up the first question and kind of run through it. So, just at a high level for our audience, can you just tell us how you would describe what an IoT analytics platform is to somebody who's maybe kind of new and trying to understand exactly what the role it plays?
Mm-hmm. Yep, absolutely. So typically we view IoT analytics platform as like extended versions of like general purpose analytics platforms. Like all companies, they are building some sort of data lakes or
Right.
analytics platform that include typical standard capabilities. Basically, you need to ingest the data, you need to establish processes for data transformations, data quality control, data governance, data access layers, and so on. Also, you would build some ML platform capabilities on top of that to develop and manage and serve different types of statistical models and so on. But these are generic capabilities. But when it comes to IoT space, generally you need to develop a number of extensions to it. Of course, it includes more specialized data collection capabilities, because you obviously need to collect to like sensors, IoT devices. It requires to deploy typically some parts of this platform on edge and manage the services for data collection.
Mm-hmm.
Then it also, in many cases, companies are building specialized capabilities to process IoT events, specifically building like rule engines or building specialized services for that facilitate the development of specialized models, such as predictive maintenance or visual
Right.
quality control. And then these models need to be deployed back, in many cases, to the edge devices or directly connected devices. So this, like all these capabilities together, like in my view, they constitute this IoT analytics platform essentially.
And when we think about IoT, there's kind of obviously different segments of the market, but a big one that at times can cause us to think in different ways is when we're thinking about general IoT and industrial IoT. And as it relates to analytics platforms, do they differ, or should we be thinking about them in a different way, and how they're maybe applied to the industrial space, Industry 4.0, or and then outside of that for more non-industrial use cases and applications?
Yeah, definitely, in my view, there are like differences between these cases because when we are dealing with like industrial use cases, meaning that we have, let's say, some physical facilities like factories, there are some implications of that influence the design of the IoT analytics platform. Let me give you like an example.
Perfect.
In many cases, when like large, especially large manufacturing companies building their IoT platforms, they face the problem that they need to connect to multiple facilities that can be operated by different third parties like suppliers or OEM partners, and these facilities can be located in different countries. It's very common, for example, to have these facilities, let's say, in Asia, and there are different protocols and rules how these facilities can be accessed in terms of data collection. In case of, for some suppliers, you can directly connect to specific like devices and equipment. For some suppliers, you cannot do that. You can only like send specifications, essentially like black box companies to you. And by this reason, in the case of like industrial IoT, it's like, at least in our experience, it's very common to like spend significant effort and make design decisions that facilitate this global integrations, and there are security aspects to it, of course,
Right.
as well, and so on. And all these capabilities, they're not necessarily the case for other like verticals within IoT space. For example, if you're just collecting data from just your local let's say, actually the opposite example is collecting IoT data from consumer devices, which is like totally different, right? You would not have this problem. You can use cloud services for that more efficiently, and so on.
Gotcha.
So it will be major difference, of course.
And when it comes to, when we say like for a company to build an IoT analytics platform, let's focus on Industry 4.0 here for a second. What does it mean for a company to build one, or in a sense adopt one for their business? How do you kind of go about that, or how do you, I guess, advise companies to go about that adoption and building an analytics platform for their business, for their use case, and so forth?
Yep. I think, like in our practice, we actually seen several good strategies how you can go about it, and a specific choice of the strategy. I think it influenced by the few factors, including the scale of the company. Let me again give you like a couple of examples, probably. So one possible strategy how you can go about it, if you, let's say, operate like small to medium size like company with relatively few facilities and relatively few devices, is that you can start with basically like data collection and doing some exploratory data analysis, so that all the data that you potentially can collect from your sensors and devices are aggregated, and you can actually like monitor this data. You can establish then some basic capabilities such as monitoring, some exploratory data analysis, some basic analytics, and then you can start to improve your like operational decisions, build some maybe rule engines, and gradually increase the complexity, then build maybe more like predictive models and so on, and try to cover broader range of use cases and so on. But this approach, it actually in my view, it works well only to a certain scale, because if we operate like if we are talking about like large companies, like large manufacturers, they cannot really start with collecting all possible data from all facilities and all devices and all the sensors. It's just not feasible, and even if they're able to collect all this data, it's not really possible to do meaningful analysis of all this data at the same time and operationalize it. And it leads us to a different strategy that is basically use case driven. In that case, better approach is typically to identify some priority use cases, and this is also not a trivial problem. There is typically some methodology, some approach doing that. But then once this use case is identified and the business value, potential business value for this use case is estimated, several things can go in parallel. First, in many cases, it makes sense to start with some prototyping. It's not necessarily related to building like the complete platform as such. It's just around building some, proof of concept models or something like that. And in parallel with that, you can start to establish more foundation for productization of these POCs, building a more complete platform that addresses, all these different concerns that we talked about, like data collection, deployment on edge devices, and so on and so forth. And then at some point, these different work streams, they come together. Of course, the POC will ultimately be productized and deployed on this platform. And then you can start to onboard more and more use cases. This is what we've seen for basically larger companies.
And as this is deployed and you start to see success, you're adding use cases to it and so forth. What best practices, I guess, advice would you give on how to approach the managing of the platform as it grows?
Well, I think there are actually several aspects to it. Obviously, there is some like business aspect. How do you pick the use cases and what you basically invest in into, and how you evaluate the impact and so on. This is one part of it. But I think your question is more about technical aspect, how you operate this platform. And from that perspective, also there are like a few best practices. I think. Just to provide a few examples. First one is that like data quality and understanding of proper understanding of the data semantics is very important, because if you cannot ensure good quality of data, and in like IoT use cases, this is like particularly prominent because of different connectivity issues and so on, then it can basically invalidate all like downstream analysis or whatever you do with this data. And understanding the semantics of the data, I think it's also very important, because for some use cases such as anomaly detection, it's very easy, for example, to build, let's say, anomaly detection model that actually mismatches the actual semantics of the data and does not detect, let's say, meaningful anomalies. So this, understanding of data completeness, doing data quality checks, making sure that data semantics is well understood in the downstream analysis, I think it's very important. And then the second example, just the second example that I wanted to call out is like observability of data collection and inference processes. I think it's also very important, especially in use cases that involve like automatic real-time decision making. It's of course important to collect data not only from IoT devices, but also collect data that characterize how models or whatever logic you deploy is performing, control different types of drifts or some anomalies in these processes, to making sure that the operations, the decision-making, decision automation processes are valid.
And when this is deployed within an organization, is it recommended that they have someone internally that helps manage this day to day, or is this something a third party, kind of like your all self, would help manage as it gets rolled out and scales? Like what's the best kind of approach there for a company?
Well, typically, I typically, like in my experience, this is like two-layer approach. You basically, in most cases, you would have some sort of infrastructure or like platform or operations team that basically is responsible for creation of these foundational capabilities, like general data quality control or deployment capabilities, observability capabilities. And this team, they can include more like operations type of resources that like doing day-to-day monitoring and so on. And of course, it will be some counterparts, maybe in physical locations, like on the actual facilities, but I think it's the kind of separate. And then on top of that, the second layer are teams that actually like implement specific use cases. And these teams, like in many cases, they also responsible for like doing at least like second level or third level of support of production solutions and making incremental improvements on top of that. So this is not the only possible approach, but I think it's most typical one. This this two layer.
Yeah. Makes sense. Yeah, absolutely. Last question I have for you before I let you go here is you've already mentioned a couple different use cases. You talked about teams focused on use cases and how that can kind of help with success. What are some of the use cases in the industrial space that really lead the way when it comes to IoT analytics platforms?
Well, I think different use cases related to automated quality control are really like important, and it's quite obvious because these use cases are directly related to different costs, either cost of quality control or what
Right.
costs associated with recovery from different defects and failures. So we see that currently like many companies that not only manufacturers but companies that somehow associated with physical operations, they like invest a lot into this type of use cases. It can include anomaly detection in numerical metrics, also visual quality control is in different flavors of it are very popular. So this is one large group, and I think this is probably like the most important and the most common one. But also there are like other areas that I think gaining traction, such as let's say automated dynamic process control. You can collect different metrics or like images, videos, do some analysis based on that, and then dynamically make adjustments to parameters of equipment to ensure that certain level of quality or stability of the outcomes. And this is also very important from the business value perspective, because it helps to achieve like quality levels and stability of quality that cannot be achieved using, for example, manual parameters management or some other techniques.
Fantastic. Yeah. So last thing I want to ask before I let you go here, for our audience out there who wants to learn more about what you all do, learn more about these analytics platforms, how they can adopt what it goes into them, follow up with questions, that kind of thing. What's the best way that they can do that?
Well, I think there are like several ways, like several types of resources that they can use, because there are different types of solutions how this problem can be approached. First one is that there are some like third-party products that position themselves as IoT platforms specifically, and these are resources that, of course, one should check and be familiar with what are the capabilities of these products. But this is just one possible approach, and like in our experience, capabilities of this platform are somewhat limited or specialized. Like more general approach is to build solutions using like cloud native services provided by hyperscalers like Amazon or Google or Azure. I think these hyperscalers, they currently very good in providing IoT related capabilities like specialized services specifically for IoT deployment and so on. And again, I would of course recommend anyone who wants to understand this space to get familiar with what is provided by hyperscalers. And then, of course, there are a number of different publications that describe how to build specific use cases, using custom models, how to address this data quality topics, and so on. So in particular, we have quite a good library, like publicly available library of articles and white papers on this topic.
Okay. And that's just then go to your website, kind of check that out and learn more, connect if they want to. Okay. Perfect. Well, thank you so much for taking the time. Fantastic conversation. Really appreciate it. And look forward to getting this out to our audience. So thanks for being here. Really appreciate it again.
Yeah, thank you. Appreciate the opportunity to to have this conversation.
All right, everyone, thanks again for watching that episode of the Ask IoT video series. I hope you found a lot of value in it. If you did, please be sure to like the video and subscribe to the channel. It helps others find it and make sure that you get the latest episodes as soon as they become available. Other than that, if you have any questions or topics that you would like us to cover in this series, please leave them in the comments or shoot us an email at hello@iotforall.com. Other than that, thanks again for listening, and we'll see you next time.